In this video, I'm going to show you how to approximate the circumference of an ellipse without calculus, for those of you who haven't taken it, and also how to get the exact answer with calculus, for those of you who have taken it. So let's start with this example. Let's say we have an ellipse defined by this equation, x squared over 9 plus y squared over 4 equal 1. Let's graph the ellipse, and then let's estimate the circumference of it. Now this ellipse is centered at 0, 0, and we need to find a and b. This ellipse is in the form x squared over a squared plus y squared over b squared, which equals 1. A is always larger than b. So therefore we can see that a is the square root of 9, which is 3, b is the square root of 4, which is 2. So notice that a is under the x variable. So therefore, we need to go 3 units to the right of the origin and 3 units to the left. So the vertices of the ellipse is going to be 3, 0 and negative 3, 0. B is equal to 2, and it's under the y variable, so we're going to go up and down 2 units from the center along the y-axis. And so now we can plot the ellipse. And so it looks like that. And so this is B, which is equal to 2, and we can see that A is equal to 3. So how can we calculate the circumference of an ellipse? Now, using calculus, there's 2 equations that you can use. Here's the first one. So the circumference C is equal to 4 times the definite integral from 0 to pi over 2 square root a squared cosine squared theta plus b squared sine squared theta d theta. Now here's another form which comes from this form. It's 4a times the integral from 0 to pi over 2 square root 1 minus e squared sine squared theta d theta. If you're going to use that form, you need to know that E is the eccentricity of the ellipse, which is c over a, and c is the square root of a squared minus b squared. Now I'm going to use the first form because I don't need to calculate c or e. So this is going to be 4 times the definite integral from 0 to pi over 2. A is 3, so a squared is 9. B squared is 4. And this is what we have. So if you have access to a graphing calculator, go ahead and type this in. Or if you have a scientific calculator that can calculate the value of a definite integral, you can plug this in. If not, search for an online graph calculator that can do this. So if you type this in, this is what you should get. At least this is what I got based on my calculator. I got 15.86543959. One thing I want to mention is that you need to make sure your calculator is in radian mode. If it's in degree mode, then you might get a different answer, so just look out for that. Now let's estimate the circumference using 2 different formulas. So let's say if you're taking a multiple choice test and you need to calculate the circumference of an ellipse, and all of the answers are very far apart, then the quickest way to get a decent approximation is to use this equation. The circumference is approximately pi times a plus b. So if you think of this equation, c equals 2 pi r, and you say that r is approximately the average of a and b, then you can come up with this equation. The 2's will cancel, and you get pi plus ab. And for the most part, the answer is slightly off, but it's still a decent approximation. In this case, A is 3, B is 2, so the circumference is approximately 5 pi. So if you plug in 5 pi in your calculator, you should get 15.70796. So as you can see, it's slightly off, but if you're rounding your circumference to 16, then this is a good approximation. Now, if you want a better approximation, you can use this formula. That is, C is approximately 2 pi times the square root of a squared plus b squared divided by 2 plus our pi times a plus b, all divided by 2. So let's go ahead and plug this in. So a squared is 9, b squared is 4. And we're going to divide that by 2 inside the square root. And then a plus b, we know it's 3 plus 2, that's 5. So this is plus 5 pi, all divided by 2. So be careful with the way you plug that in. So we have the square root of 13 over 2, all inside the square root, times 2 pi, and then plus 5 pi, all divided by 2. And so this is equal to 15.86350276 based on my calculations. And so if you're rounded to, let's say, 15.9, it's a good approximation. If you're rounded to, let's say, the 100th place, then this will give you 15.86, and this will give you 15.87. So it's close, but it's not exact. But nevertheless, this is still a good approximation. Now let's work on another example. Let's say that we have the ellipse x squared over 36 plus y squared over 25 is equal to 1. Go ahead and find the circumference of the ellipse. Go ahead and calculate it. So a squared is 36, which means a is equal to 6, and b is the square root of 25, so b is 5. Let's start with this equation. So it's 4 times the integral from 0 to pi over 2, square root a squared cosine squared theta plus b squared sine squared theta d theta. A squared is 36, and b squared is 25. I'm going to show you how to evaluate this integral using an online calculator. But once you type it in, you should get this answer, 34.62895598. So that is the circumference of the ellipse. So let's go ahead and approximate the answer. Let's try this one. The circumference is approximately pi times a plus b. So in this case, a is 6, b is 5. So it's approximately equal to 11 pi. And 11 pi, that's about 34.55751919. In this case, both answers round to 34.6. So this is a good approximation of that answer. Now let's use that other equation. C is approximately equal to 2 pi times the square root of a squared plus b squared divided by 2 plus pi a times b, all divided by 2. So a is 6, which means a squared is 36, b squared is 25. And we know this is going to be 11 pi. divided by 2. Go ahead and type that in. So I got 34.62877,211. So this answer is very close to that answer. In both cases, they round to 34.629. Now let's talk about how we can derive the formula that we have been using to get the circumference of an ellipse. So let's start with this equation. X squared over a squared plus y squared over b squared is equal to 1. And let's solve for y squared. So I'm going to take this term, move it to the right side. So I'm going to have y squared over b squared is equal to 1 minus x squared over a squared. And now I'm going to multiply both sides by b squared at this point. Next, I'm going to take the square root of both sides. The square root of b squared is b. So this is what I now have. In order to derive the formula of the circumference of an ellipse, we need to use the arc length formula. So it's going to be the integral from alpha to beta of the square root of 1 plus the derivative of y squared dx. Now let's talk about the graph of the ellipse. So this is a, negative a, b, and negative b. And it correlates to this function, x squared over a squared plus y squared over b squared, which is equal to 1. And so what I'm going to do is I'm going to integrate it from 0 to a. So this is going to give me the arc length of the first quadrant. Now I'm only going to use the positive sign because positive b times the square root of this stuff will give me everything above the x-axis. If I want the stuff below the x-axis, I have to use the negative sign. So since I'm only going to use the positive sign, and I'm only going to integrate from 0 to a, I'm going to get 1/4 of the entire circumference of the ellipse. So therefore, I need to multiply this by 4. So the circumference is going to be 4 times the integral from 0 to a, square root 1 plus. Now we need to find y prime from this equation. So y prime is going to be b times the square root of this. So I'm going to rewrite it as 1 minus x squared over a squared raised to the 1/2. So we need to use the power rule. So it's going to be times 1/2. And then we're going to keep everything on the inside the same. Subtract 1/2 by 1, so this is going to be negative 1/2, times the derivative of the inside. The derivative of this expression is going to be 2x over a squared. But it's going to be negative 2x over a squared. So let me get rid of some stuff. Right now, we can cancel 1/2 and 2. And so this becomes negative b over a squared. And this raised to the negative 1/2. I can bring that to the bottom. It becomes positive 1/2. And then you can convert that back into its square root form. So this is 1 over the square root of 1 minus x squared over a squared. So for y prime, I have negative b, and let's not forget about the x, divided by a squared times the square root of 1 minus x squared over a squared. So now at this point, let's plug all this into the arc length formula. So it's going to be 4 times the integral from alpha to beta, but we're going to go from 0 to a, and then it's going to be square root 1 plus, I'm going to need a bigger square root symbol, 1 plus this thing squared. So it's negative bx over a squared times the square root of 1 minus x squared over a squared squared. And then there's a dx in front of that. Negative b squared becomes positive b squared, and then times x squared. And then a squared squared, that becomes a to the fourth. And this square would cancel the square root symbol. And so this is going to be 1 minus x squared over a squared. Now this expression, I'm going to rearrange it. A to the fourth, I'm going to write it as a squared times a squared. And then I'm going to distribute one of the a squareds. So a squared times 1, that's going to be a squared on the inside. And then a squared times x squared over a squared. These two will cancel. And so I'm going to get negative x squared. So let's rewrite it like that. At this point, we need to use trig substitution. So I'm going to make x equal to a sine theta. And so dx is going to be a cosine theta d theta. Now I need to change the limits of integration. So these are x values. I need to change them to theta values. So when x is 0, what is theta? So let's plug in 0. So 0 is going to equal a sine theta. If we divide by a, 0 over a is 0. And sine 0 is equal to 0. So therefore, the first theta value will be 0. Now what about when x is equal to a? What is theta? So replace x with a in that equation. So if we divide both sides by a, we get that 1 is equal to sine theta. And sine pi over 2 is 1. So the second theta value is pi over 2. So this is going to be 4 times the integral from 0 to pi over 2 times the square root of 1 plus b squared. And then we have x squared. X squared is going to be a squared sine squared theta. And then it's divided by a squared times a squared minus a squared sine squared theta again. And then times dx, which I'm going to replace that in the next step since I'm running out of space. So at this point, we can cancel a squared. And we could also factor out a squared in the bottom. So this is going to be 1 plus b squared sine squared theta. And then if we take out a squared, we're going to have 1 minus sine squared theta. And dx, at this point, we can replace it with a cosine theta d theta. Now we can replace 1 minus sine squared theta with cosine squared theta. So we're going to have a squared times cosine squared theta. And then a cosine theta, that's the same as the square root of a squared cosine squared theta. So I'm going to take what I have here and distribute it to the two terms there. So if we multiply this by 1, we're just going to get a squared cosine squared inside the square root. And then if we multiply these two terms, a squared cosine squared theta will cancel. So now we have the exact formula that we use to calculate the circumference of an ellipse. Now let's talk about how to get the other formula. So what we're going to do is we're going to replace cosine squared with 1 minus sine squared. And then we need to distribute the a squared. So it's going to be a squared minus a squared sine squared theta plus b squared sine squared theta d theta. So now let's factor out a sine squared. So if we take out sine squared, what are we going to be left with? I'm going to factor out a negative 1. So it becomes positive a squared minus b squared times sine squared. Now it's important to know that c squared is a squared minus b squared, and the eccentricity of an ellipse is c over a. So this becomes a squared minus c squared times sine squared theta d theta. So at this point, I'm going to take out an a squared inside the square root. So if I factor out an a squared, I'm going to get 1. If I take out an a squared from this becomes c squared sine squared theta divided by a squared. And so if you redistribute the a squared, these will cancel, giving you c squared sine squared theta. Now the square root of a squared is a, so I'm going to move the a to the front. So I have 4a times the integral from 0 to pi over 2, and then 1 minus, now we said that c over a is e, so c squared divided by a squared is e squared. So this is the other formula that we could use to calculate the circumference of an ellipse. So what I'm going to do at this point is show you how to calculate the definite integral. So in your search engine, if you type in definite integral calculator and click Wolfram Alpha, and then you could type in the function. For the first example, it was 4 square root sqrt brackets, and then it was a squared was 9 cosine x squared, that's shift 6, and then plus b squared was 4 sine x squared, close brackets, and we're going to integrate it from 0 to pi over 2. Now if you don't see your answer here, click this equal sign at the bottom right. It's taken a while, but it will come. If you click more digits, then this will give you a more accurate answer, which is 15.865943959 if you round it. Now let's go back to this page. To get the answer for the second problem, we simply need to change some numbers. In the second problem, a squared was 36, so replace 9 with 36, and b squared was 25. And then just click Submit. So I'm going to click the equal sign at the bottom right. And so this is the answer that we had, 34.62895598. So anytime you need to calculate the value of a definite integral, if you don't have the calculator for it, you could use this.